Okay, guys. All right. So yesterday I tried to start filming this, but then I had to stop. So I just got a little bit done on it. But this is our last unit lesson. So after this lesson, we're going to do this on Thursday during class, and then Friday we're doing something fun and for homecoming, and then Monday is review, and then Tuesday's our test. So just to kind of give you a timeline there. Then we'll head into Unit 3. So here we are as we're taking the phrases that we have learned, and we're going to input those into the phrases that we learned yesterday, and we're going to input those into word problems. So we can use the word problem, and set up an inequality to solve. So this one, let's see, it says Albert earns $3.50 for each hour he works. If he wants to earn at least $52.50, how many hours must he work? So we know he wants to earn at least $52.50. So if we look back at our notes, at least is greater than or equal to. It doesn't say is at least, it's okay. So greater than or equal to at least $52.50. So we know this part that's this part of it. So how is he going to get to this amount that he needs to work? It's by working hours. So he gets $3.50 for every hour he works. And each hour is an X. Okay? Each hour is represented by X. So this is how you would set it up, and then we would just solve it. And all we have to do to get the X by itself is to divide off 350 from both sides. Okay, over here that cancels. You're left with just X, same sign because we didn't divide by negative. And then there is just a calculation. $52. You cannot see that. $52. Okay, there we go. $52.50 divided by $3.50. $3.50. It's 15. $15. Okay. So, not $15. It's not in dollars. So down here, we're going to just put our inequality that we wrote here. And then we figured out that X has to be greater than or equal to 15. So he has to work at least 15 hours. Okay? At least 15 hours. All right, let's look at this next one. The daily production cost for a skate factory cannot be more than $55,400. Okay? It costs $15 in materials to make each pair of skates. Each pair. And the daily operating, it's going to give us a plus here. Daily operating costs are $900. How many pairs of skates, that's what we're looking for, can be produced given these restrictions? So here's our phrase that's going to help us. Cannot be more than. Okay? We look at our chart. Is no more than is the same as cannot be more than. Okay? Cannot be more than. And that is a less than or equal to. Okay. How many pairs of skates can be produced given these restrictions? All right. So here, let's just map out what we have here. It costs $15 for each pair of skates. So each pair of skates, where we see each, we know that's probably where you're going to have your X value. Each means per skates, so $15 per skate. In materials and daily operating costs of $900. So $15 per skate, per pair of skates, plus $900 a day. And we said our sign is going to be less than or equal to, because of this cannot be more than, and then 5,400. So that's how we set that up. So let's go ahead and put that down here. It's part of our answer. And then we just need to solve. Okay, so let's go ahead and solve. We're going to get the X by itself. Let's move this number to the other side first. So that's going to leave us with 4,500. And this cancels. So it's 15x is less than or equal to 4,500. So now we just need to divide each side by 15 to get that off the x. And we're left with x is less than or equal to 300. So they can produce at most 300 pairs of skates a day. Okay, 300 skates. Well, let's clarify this. It was 300 pairs of skates. All right. On the back, next page, a group of 3 friends went to the movies. After paying for their tickets, they had a total of $10 to spend on refreshments. So their total was $10. Is how much they totaled, or they had to spend. Sodas cost $1.50 each. These were each. And a box of popcorn cost $1.75. How many sodas can they buy if they purchase 2 boxes of popcorn? All right. So right there, we're going to have to do a little bit of math beforehand. So 2 boxes of popcorn, if they're $1.75 each, that's going to leave you with $3.50. Okay, for popcorn. That's how much you're spending on 2 boxes of popcorn. All right, so here we know that we have a total of $10. So if we look at our phrases, so it cannot be no more than $10. No more than. Total. It's the same thing as no more than. At the maximum limit. Okay? So we're going to be using less than or equal to because of this word total here. All right. So how many sodas can they buy? So sodas is going to be our X. That's what we're trying to find. Sodas are $3.50 or $1.50 each. So 1.50x plus our $3.50 we're spending on popcorn has to be less than or equal to $10. So now we can start to solve for x and figure out how many sodas they can buy. That's what we're trying to figure out. That sodas is our x. So we're going to subtract 350 from both sides. And we need to line up our decimals. But you can also just do this on your calculator. minus $3.50, $6.50. Okay, so that cancels. So $1.50x is less than or equal to. So now we just need to divide by 1.5 on both sides to get the x by itself. And we do end up with a decimal, 4.3 repeating. So we know now that our x is less than or equal to 4.3 repeating. And that means that they can only buy at most 4 sodas. Because you have to have it in whole numbers. You can't just buy 4 1/3 of sodas. And if you bought 5 sodas, that would be too much. So you don't have enough money for that. Okay? We're going to skip this one. And then we're going to go to number 5. On an interstate highway, the maximum speed, maximum here is a key word here, maximum speed is 70 miles per hour. And the minimum speed is, minimum might be a key word here, 45 miles per hour. If x represents speed, then write the inequality to express this condition. Okay, so this is a condition. That means that we're not really going to solve this inequality. We're going to have a minimum and a maximum. So our maximum is 70. So that means that our x, if our maximum is 70, if we look at our keywords, less than or equal to. X is going to be less than or equal to 70. And our minimum is 45. So that is greater than or equal to. X is greater than or equal to 45. So the condition wants us to do a minimum and a maximum all in one statement. And we're just going to put, like, you can go between this and this, between the minimum and the maximum. So the minimum is 45, right? That's your minimum. And so your maximum is 70. So your speed, which is your x is your speed, has to be between 45 and 70. So that means your x has to be greater than or equal to 45 in where the x is concerned. Not, I know this is a less than sign, but if you're reading it from the x's perspective, it's a greater than, because the greater than side is open to the x. Or the x has to be greater than or, less than or equal to 70. Cannot be more than 70. Has to be greater than 45, but less than 70. Okay? And I know this is tricky because this looks like less than. You would read that, you might say, oh, it's less than 45, but no, the x, from where the x is, the speed has to be greater than 45 or equal to 45. And that's all we're going to do for that. Okay? That's the condition. All right. Have a good night.